Hello guys, my name is Patrick Mensah, and today I'm going to talk about matrices, arrays, lists, and data frames. So when you talk about matrices, we all know matrices from high school and then college algebra. So now if we want to create a three-dimensional array consisting of 24 numbers in a sequence from 1 to 24, with a dimension 2, 4, and then 3. So this one is generating a number from a sequence from 1 to 24. And then the dimension here would generate 2 rows, 4 columns, and then 3 tables. So we do that. Let's run this and see. So this gave us three tables, and then which we have 2 columns, 2 rows, and then 4 columns each. And then let's look at another way of which we can also do it. This one also does the same thing. So the dimension, then changing it. So this one is creating 4 tables where it's giving us 3 rows and then 2 columns. So if we look at this here, this one, if you see that it gives you 3 rows and then 2 columns here. This is also another way of checking it. Now let's look at arrays. So arrays too, you can use this this one to generate a number from 1 to 24, which generates 4 rows, 3 columns, and then 2 tables within the array. So we create a variable like this, and then we run it. So this is giving us 2 tables where we have 4 columns, 4 rows, and then 3 columns. So that is basically that. Now let's look at a different way of writing matrices, and this is just the basic one. So we use this to write a matrix. So this one is generating these numbers, and then the number of rows is supposed to be 3. So we look at this. Let's run this one. We run it. So you can see that this is giving you 3 rows, and then 4 columns. So let's look at this. You look at the class, and it tells you that matrix and array, and then the attributes. It tells you what type of matrix it is. So it tells you that it's a 3x4 matrix. We can also do the same thing over here to generate these numbers. That gives you 4 rows, and then so we look at it. We have 4 rows. Then the number of rows is 4, and then the columns is 3. So we can look at the class, and it tells you matrix and array, and then we can also check the attributes, and it tells you 4x3 matrices. Now let's look at this. This is where we by default it's arranged in a column. All the matrices will arrange in a column, but now there can be a situation where you can arrange it by row. So you create the numbers, and then here we use by row. So when you do it through, then it means through. So it means that it's going to arrange the numbers by row, and the number of columns here is 4. So we run it here. And here you can see that the numbers were arranged by the row. So you can see that 12, originally it's arranged by column. So now you can see that it is arranged by the rows. That is how it is done. So if you use the by row is equal to false, that it means that it's going to arrange by column. That is by the default. So this one is going to arrange by column. So we run this. And this, so you can see that it is arranging the numbers by column. So now let's look at how we can convert a vector to a matrix. So now we have this vector over here, and we want to convert this one to a 4x3 matrix. So we look at this. we look at here, we use this code to run it and then see whether it is a matrix or not. So we look at this, run it, and then we run this. You look at it. Here it's giving you a 4x3 matrix. So now we can check whether it is a matrix or not. When you run it, it tells you that we have been able to use this code to convert a vector into a matrix. Now, if you want to find the transpose of a matrix, we call this function T here, T of the vector. So we have, if you have a vector, now this is the vector we are talking about, because this vector has been transformed into a matrix already. So I create this variable called transpose, and we use T, then the vector. You see, we look at this over here and then we transpose it. You can see that this here, which was a 4x3 matrix, and is now 3x4 matrix. So now let's look at how we can deal with data frames. Data frames is where we have a lot of vectors and then we combine them into a data. So this one, it helps you to, if you want to find the mean, whatever in a data, and then they are all in vectors, you have to combine them. And then by combining them is what makes it a data frame. So for example, if we create this and then we create a sequence from 1 to 10 by 1. So it's going to generate numbers from 1 to 10. And it jumps one after the other. And then the alpha is generating the first alphabet letters. This one, this code, it will generate the first alphabet letters. And then this code, I did this code to create a logic like the Boolean, that is a true or false, true or false. We sample the 5 truths and then 5 false, and they should be mixed together. And this is the code to do that. So we run this one, we run this, and then we run this. Now, if we want to combine all of them into a data frame, you can combine all of them by using the cbind function. If you click on cbind, the cbind is, and then you bring all these numbers together. It's going to bring all this data together. So we run this code and then say, let's assume combine. So if you're able to combine it, you can look at it. Combine here. Let's look at how it is. So now this is how the data is. If you want to look at it as like how it's supposed to be in a data frame, we use this function. Combine, and look at how nice it is. So it means that we have been able to create a data frame for this. So now let's look at how we can make data frames with this. I mean, another way you can do it's just we create a new variable in a data frame, then you use the combine. The combine here is all of this combined together. So you look at this one over here, and then you do it. It also produces almost the same thing. It's nice. But look at the difference over here. You see that here, the alphabets have it looks like a string, and then all these values look like a string. That is not what we want. So we want something like this. We want something like this. So, and then one of the best ways to also do it is to cohere all of them into a data frame by using the cbind. And let's look at how it's going to be. Look at it. This shows where it shows that it's a very nice thing over here. And this is how we combine vectors into a data frame. Now, let's look at listing. So with this listing, you can combine all this together as a list. So this, I've already talked about it, so I'm not going to talk about it again. So let's run this code, and then if we want to put them in a list, you use the list function. So let's say list paths is just a variable I created. So the list here, we'll put all of them into a list. So let's look at this one over here, and you run it. You can see it over here. Now we see list within a list. This looks like it's something complex, but basically it's not complex. So let's look at it. the list part that we created over here is here. Now we are going to put them into another list and then see how it's going to show. You put them into a new list, and this is how it shows. Something nice. It's very simple. So that is all about list. There are so many things we can talk about lists, but I think this is all what we need to know. Now let's look at how we coerce types of data. So for example, I created this data as parts. So parts here, it has 3 characters, 2 numbers, and then 3 numbers, and then 3 Boolean values. So you can see that we run it over here. Now we don't know what type of data is, but if you do it, a type of data, the data is going to show you a character variable. It's not just because it's in front, no, but so that is how R is programmed. So look at it, and it tells you that it's a character variable. Now you can convert numeric values into integers. So for example, I created this one here, and this one from the previous videos is going to create a sequence from 1 up to 10, and it's going to jump it by 2 steps. So 1 up to 9. So this is also another way of writing odd numbers less than 10. This is very simple. So you just do it like this, and these are the values. Now we look at the type of the number, the type of part, and it tells you that it's double. So it's double position by default. Now let's look at how we can convert or coerce this one into an integer. So we use the as integer function to do that. So we run it, and we run the part. It shows the same number, but what type of part new is it? It tells you that it is an integer. This is just because we have been able to use the as integer to coerce the part. Now let's look at how we can change characters or coerce characters into numeric. So for example, we have this characters. Remember 1, 2, 3 is not in, this one is not a character because they are in quotation marks. So it's not it's not a number, it's not numeric, it's a character. So we can also use the letters in any of them will work. So let's look at it. It tells you that it is a character. Now let's look at how the type of it, and it tells you it's a character. Now we can force it to be a numeric. So let's force it as numeric, and then it tells you that now once you show the double here, it tells you that the number is numeric. The part 2 is numeric. Now let's look at how we can coerce a matrix into a data frames. Now, for example, I have talked about this matrix already. It tells you that this is a matrix, and then let's look at this one and see whether it's a matrix. You look at it, asking whether it is a matrix. It tells you true. Now we want to convert this one into a data frame. So we call something as data.frame of mat2. So the mat2 here is the matrix here. So we can make it a data frame with this function. So make data frame is what I used. So you make a data frame with it, and then you run it, and it shows you everything over here. So now this one is telling you that it is a matrix. Now, if you want to, you can also view it. You can also view it. You can view let's call it data frame, and it shows everything here like a data frame in a very nice way. So this is how we can do it. Another way you can also do it is that here we generated number from 1 up to 4, and then the number of rows is 4. 1 up to 28, and the number of rows is 4. So and then we try and see whether it is a matrix or not. So we run this one, and then I'm asking whether it is a matrix or not. It tells you that it's true, telling you that it is a matrix. Now, if you want to force it to become a matrix, to become a data frame, we use the as data frame function, and then let's see what it's gonna give you. So this is how it has been able to generate. And then if you want to force it to edit, if you use this function as as dot. This one is if you want to ask. So it's part underscore matrix 1 editor. And then it's telling you that it's true. It's part. Okay, this one is for the first one. So I don't think this one is very important. So this is basically how everything is done. So it's a very nice. It gave you a force because you have been able to force it into a data frame. So it is no more. It shows the force here because now the force here is telling you that the part underscore matrix 1 has already been converted into a data frame. So it's no more a matrix. If you want to convert it back to this thing, you can also do that, and it's still going to work. So basically, that is how it is done. That is all for today. Thank you so much for your time.